Hey, Thomas. Good morning. Good afternoon, actually, unless you're outside. Well, almost good afternoon here in Eastern Time in about 5 minutes. But good morning, everybody. We have an emergency briefing here as we have a monster nor'easter to discuss for parts of New England, parts of the Northeast. And we do have some shifts, too, in the morning model runs. We are definitely starting to see a bit of a shift inland with the heaviest snowfall totals, and that's across the board with those model runs. Here I'm just showing you the operational GFS member, hot off the press. This is from pivotalweather.com, an incredible website to visualize model data. And this shows the max snowfall totals here in northeastern Pennsylvania now, just a little bit inland from the I-95 corridor, but the majority of the models still dump a foot at least there in New York City before mixing with or even changing with a little bit into a pure mix, probably sleet to hold down those totals. There is just a bit of a northeastern shift of this heaviest snowfall total. Earlier, it looked like it was going to be a little bit further southwest. And we're going to break down exactly what's causing this shift by breaking down these model ensemble members. So even though for the most part, we often look at those operational models and look for the trends in there, it's best to look at the ensembles to kind of get an idea of the uncertainty within the model. And this is the GFS ensemble from the morning model run. And you can see that this right here is obviously an outlier, ensemble member 2. A couple of other outliers here as well. Then you get closer to the operational member here, which definitely has that bullseye in northeastern Pennsylvania, as does this outlier. But really, you just kind of look to see what the spread is amongst these different ensemble members and to see if that northwestern trend is consistent amongst all those members. And you can definitely see that northern shift of this bullseye, even though some of the ensemble members differ in the total amount of snow that's going to fall within that bullseye, almost every single one is showing that this ensemble member here has that slug in southeastern Pennsylvania into northern New Jersey, kind of like the last one there. But a majority of these members definitely are showing that heaviest snow from central northeastern Pennsylvania across southern New York, just inland from New York City there. And the NAM is showing it even more pronounced. So I'm going to show you the NAM here as well really quickly. And those ensembles that I just showed you are from the College of DuPage model visualization site, which is an incredible website to look at forecast models, the ensembles especially. They've got a great forecast model display for those ensembles like the GFS and the European. But this is the latest NAM model forecast. And this is the regular NAM here, not the 3 kilometer NAM. And this NAM was the first model where we started to notice this northwestward trend with the heaviest snowfall totals, kind of like that, northeastern Pennsylvania, southern New York, just inland from New York, then across even the Berkshires, even southern Vermont and New Hampshire get in on the action. But the NAM shows a lot less right along the coastline, including New York City, with just 2 to 4 or 5 inches of snow. And that would probably be considered a forecast bust by New Yorkers now, since they're anticipating 1.5 feet of snow. But this just shows you that these nor'easters can change right up until they come ashore. You can have a lot of uncertainty with these. This could easily wobble back to the south once again. But we're going to break down the meteorology behind this northwestward shift and see exactly what's going to happen. I tend to believe the NAM. I'm kind of a big fan of the NAM model. I think that with these nor'easters, they intensify so rapidly. Often the models will underestimate the warm nose that is capable of wrapping ahead of that surface low and even back behind it a little bit. You're going to have sleet and freezing rain back behind this thing even after the surface low passes. So it's a monster warm nose that's coming in. Also elongated in the southwest to northeast direction, almost a double-barreled surface low. And I was worried when I saw the models showing this double-barreled low where you kind of have an elongated zone of low pressure just offshore. Sometimes you can get a little bulbous area of low pressure that'll form all along that. And that can also, the timing of how that surface low evolves and the shape of everything can definitely determine that could definitely change that bullseye quite a bit from where it's located now. But definitely the models are showing a shift to the northwest. It's just the models do differ as to how much snowfall falls before that precipitation changes over to a mix. The HRRR, GFS, they show over 1 foot falling in New York City before it changes over to that mix. The NAM and the high-resolution NAM show less near the coastline, and they seem to be resolving that warm nose a little bit better. But also with this northwestward shift, it brings a band of heavier snow to the west of the max as well, and that extends back down into the Pittsburgh area. I think that this is more deformation zone banding back here, stretching out. So I do think that there's going to be quite a bit of snow in Pittsburgh, probably in excess of a foot as well. And I'm still trying to hone my plan for intercept. I'm going to kind of work the southern edge of this nor'easter a bit and then drop down and cover some of that freezing rain accumulation banked up against the mountains there. But now I want to really talk about the snowstorm that's ongoing right now in Oklahoma. Of course, Oklahoma always holds a special place in my heart, spending almost 20 years there at the University of Oklahoma. And we've got another snow event coming in here. And I saw a comment the other day that eventually one of these systems might stall out and dump a lot of snow, but I'm not so sure that's going to happen because when La Nina conditions are dominating the tropical and subtropical Pacific, usually you get a lot of waves, a lot of storm systems like this, but they're very progressive in nature, meaning that they move rapidly from west to east across the continental United States, and they'll dump quite a bit of snow, sometimes heavy snow, but they're moving so fast that you don't get those massive dumps, at least in the southern plains, that you often see when El Nino conditions are dominating the tropical Pacific. And when that happens, then you get a more buckled jet stream, slower moving storm systems, at least further west in the southern plains, sometimes even cutting off in the southern Rockies out there. And that will lead to those really prolonged periods of snow. You may remember that big blizzard that happened around Christmas Eve years ago in Oklahoma, and that was a very buckled jet stream, more of a El Nino type of a pattern. But right now today, we've still got moderate to even heavy snow extending from Woodward up to northwestern Oklahoma City. And this band right here is responsible largely for this winter storm warning that's out here. The winter storm warning does not include Oklahoma City. It's just to the northwest of there. But it does include just to the northwest, up near Yukon, northwest of there. It doesn't include downtown Oklahoma City, does include Yukon. So for those that are living in the western suburbs of Oklahoma City, you're a lot happier than those that are living in Oklahoma City. You're going to have a lot bigger snowmen being made out there, snow people. But here's some very heavy snow just to the northwest of El Reno within this band. The heaviest snow right now is falling just to the southwest of the Fairview area. This band is weakening just a little bit. Woodward, you're still getting moderate snow. Beautiful scenes of winter up there. Woodward, down through Sealing. Out there, the band just lifted north of Sealing, so Chester, Orion areas out toward Dane. You're getting hammered right now by the heaviest snow that this storm system has to offer. But this snow event's really just dumping about a 3 to 4 inch type snowfall. What makes this interesting in Oklahoma is that you had these two snow events so close together out there. And I'm sure all the news networks are out here live covering this snow event. I used to work for Channel 4 back in the day, Dominator 4, covering a lot of the severe weather in these snow events. There's nothing more fun than storm chasing for local news out there, especially in a weather hotspot like Oklahoma. When the tornadoes happen, you get the news choppers up in the air. You're on the ground relaying those reports. I'm just a little too excitable to be good at it, but I did enjoy it quite a bit. You definitely felt like you're really benefiting the people directly on the ground, warning them. So this is the that snow band. We're talking about winter weather here in Oklahoma. Elk City, you're still getting some showery precipitation as it's beginning to come to a close. Some snow showers coming through there. Not after dumping several inches of snow, 3 to 4 inches of snow down there. And it looks like we're pulling up winter storm warning data from the northeast right out here, but really about a 3 to 4 inch snowfall out here, and it's much higher in the northern edge of the winter storm warning right now because that's where that band has lifted off to the north. Oklahoma City, you do have a winter weather advisory. This band just passed through. That's probably your event right there. You may get the tail end of this main band that's lifting off to the north, pivoting rapidly, but really winter weather advisories in central Oklahoma aren't the most exciting for snow lovers, but still, you got some pretty heavy snow there just to the east of Oklahoma City right now happening. There you can see that snow. McLeod up towards Hera, east of Choctaw, northwest of Shawnee. Some pretty good snow, but it is more spotty to the southeast of that dominant band. in the winter storm warning area. Looks like another band about to move through Norman as well. 1 to 4 inches in the winter weather advisory area, probably closer to 1 for Norman and a little south of there. And a lot of that's already fallen with this initial band, as that band is pivoting to the north of the winter weather advisory area. So now I'm going to show you a little quick look at the surface map in Oklahoma, showing you some of those snowfall rates happening. 3-star snow is moderate snow out there. And you can see some of the moderate snow happening to the west and to the northwest of Oklahoma City per this surface map. But really not as impactful as the last event that came through. But here you can see the moderate snow falling in that band to the northwest of Oklahoma City that we just showed you. To the south of Enid out there, to the north of I-40. Oklahoma City, mainly light snow. Temperatures are cooler though in the last event that came through, leading to a little bit more of an efficient snowfall accumulation gauge. You still have visibilities dropping to about a half mile, 3/4 of a mile out here in this band. And still quite a bit of snow in southwestern Kansas too. Dodge City dropping 3/4 of a mile visibility, and near moderate snow, light snow up there. And some pockets of moderate snow happening in the northeastern Texas Panhandle. Has some light to moderate snow with those visibilities dropping down to about a half to 3/4 of a mile or so there. But here's the radar out of Oklahoma City, showing the more showery precipitation here. Ada, you may not get very much at all. Maybe definitely closer to an inch there, if that, down in that section of the winter weather advisory. Let's take a look at the radar up here. This is the Radar Omega app. And here's some of that precipitation across southwestern Kansas. More consistent, but lighter in nature out here. Visibility dropping to about a half a mile, and some of these heavier showery banding zones out here in southwestern Kansas. Probably beautiful scenes of winter out there with that large winter weather advisory that extends all the way into southeastern Colorado there. And this is a storm system that's going to morph into the nor'easter as it rips up the coast. And my plan for intercept is probably to leave at about 3 in the morning tomorrow, chase it up the coast. Again, here's that GFS showing the, this is the 12Z GFS showing the greatest snowfall total bullseye over the Scranton, Pennsylvania area. Allentown, birthplace of Bernie Rayno at AccuWeather. We were talking this morning about this storm a bit. But this is the GFS. Definitely a shift to the northwest. Central, northeastern Pennsylvania, southern New York, just inland. Here's a high resolution NAM. I'm a big NAM model fan. And the NAM model shows a lot less happening down in the New York City area, but still 4 to 8 inches down there before shifting over to a mix in precipitation. The high resolution NAM, you can see, resolves these ridges down here. Shenandoah, out, the Blue Ridge Mountains there in northern Virginia, even getting over 20 inches of snow. So you're probably going to see somewhere in these mountains of northern Virginia getting close to 2 feet of snow. I might even work this ridge right here and then drop down and cover some of the ice down in the Charlottesville area. May target kind of the southwestern portion of this heavier band out near Gettysburg. Some of those higher ridges just to the west of town could really get hammered in excess of 1.5 feet out there. And then you see a bit of a reduction as a lot of the banding is going to dominate this area, and then to kind of a reinvigoration of that banding there. Eastern Massachusetts and then out to sea. Coastal Maine, I think you're going to get hammered by this one as well. That's kind of what I've been telling my family members and my uncle looking at the models for this recent event that went toward the Great Lakes. As often these storm systems overperform on the northwestern side of them, and that doesn't necessarily hold true for nor'easters as it does more so for Colorado lows. But it seems to be kind of a trend this year. We're about 2 to 4 days out. The snow track is a bit too far southeast, and as you get closer to the event, it lifts a bit to the north, and it seems to be happening also with the model suite for these nor'easters, and I'm not sure why that's happening. Seems to be underdoing the strength of the upper level storm systems that are coming ashore in the Pacific Northwest. This one that's going to lead to the nor'easter in the northeast underestimated how deep that upper system would be coming ashore there in Oregon. So let's go back again to the ensembles, and let's see if we can figure out the meteorology between these two, and see why those ones that are pumping out the bullseye in northeastern Pennsylvania are happening, and then why some of these outliers are producing a bit less snow. First, I got to pull up the College of DuPage site. Weather.cod.edu. Great site for visualizing the individual ensemble members especially. But I think my plan is to leave it about 3 in the morning. And I'm going to rip up the coast. So here's the different 500 millibar shapes of those individual members. Some of these are a bit deeper than the other ones. Just some subtle differences in the shape of that 500 millibar trough coming in. And you can see that the very subtle differences that are hardly even recognizable with the eye are leading to pretty substantial snowfall differences, but still the GFS individual models are certainly locked in. Here's the spaghetti plot for the 500 millibar height contours. So definitely strong agreement for this trough, but you can see some little wiggles in here that could definitely lead to a difference in the evolution downstream of this. This is valid on Thursday evening. There it is. So my opinion is the timing of this ripple within the trough that's really going to make a difference in the snowfall. But there is pretty strong agreement on this feature with the 12Z GFS ensemble, and that's why there's strong agreement with that snowfall max shifting just a little bit to the north, northeastern Pennsylvania, southern New York. These areas are certainly going to experience the heaviest snow just to the north. And then see how that ripple flattens out a bit, and that's why you get a maximum in the snowfall further west, and then a little bit lesser but still substantial totals further east. But if you didn't have that big time high in the eastern Canada of about 1035, which I think we're having that high ended up verifying a bit further north too. Here's the 850 millibar temperature. Like a lot of cold air definitely anchored over the northeast, and that's and the 1035 high over eastern Canada is responsible for this cold air mass, cold blob of air just waiting in the northeastern U.S. for this storm system to arrive. So first, let's break down the evolution of this system from Oklahoma to the northeast. the latest GFS run here. I want to show you that high as well. So my plan is to leave at about 3 in the morning, get up into the target area within about 8 hours. Here you can see that storm system happening in Oklahoma. So we'll step forward every 6 hours here. And look at that high, 1037 high, anchored over eastern Canada. There's already hints at the coastal system there developing just off the coastline of South Carolina. Tuesday night, this is the southern stream system. This is the high that's anchored over eastern Canada. Necessary ingredient for these nor'easters is to have that monster high up there. And this is the 12Z GFS run, so this is the one that has shifted just a little bit to the northwest. Here you can see that coastal storm starting to get cranking just off the coastline of South Carolina here. Snowfall already breaking out, some snow even across the Ohio River Valley. The Appalachians starting to get snow by tomorrow morning. This is at about 7 a.m. Eastern time. And you can already start to see that frozen precipitation happening there over the southern Appalachians. And then look at that coastal storm starting to blow up over the North Carolina Outer Banks. That's at about noon. 1038 high, just dominating over eastern Canada. This is the reason why those snowfall totals are so high in New York City and the other models. Let's take a look and see what the NAM does, the operational NAM with that high, comparing the two models. So this, you can see the NAM is a bit further north of that anticyclone. They're comparable in intensity, but it is just a bit further north. And that's going to allow this coastal storm to be a bit further north as well. There you can see it over eastern North Carolina according to the NAM. And that's why it only brings about 3 to 5 inches of snow in New York before that warm nose changes things over to a mix of precipitation. This is the new GFS. Bit further south of that high, 1038. So we should look where the positioning of that high is in these forecast models throughout the day. But the GFS seems to be a bit more accurate with that surface low being right on the coastline there. And even though it's the system only deepens to about 1,000 millibars or the upper 990s, you want to focus in on the difference in the pressure between the low pressure center and this monster anticyclone. Massive 36 millibar difference, and that difference even becomes more exacerbated as the system lifts off to the east of Labrador. That's probably the place to intercept the storm system, is in Newfoundland. But you can see kind of this elongated surface low feature with the backside really dominating, and that's why you get a maximum snowfall from northeastern Pennsylvania across southern New York, and then almost a transfer. That surface low feature becomes even more elongated there as it lifts in toward the Gulf of Maine, starting to weaken. But really, this low pressure reaches its max intensity off the east coast, off the coastline of New Jersey or the Delmarva Peninsula, and that's why the snowmax happens here, northeastern Pennsylvania. Let's see what the NAM does with that track. So the NAM actually has a deeper system there in the Gulf of Maine, much deeper than the GFS is showing. And that's also why the NAM has those higher totals for locations like Massachusetts, inland in Connecticut as well. And that's because this surface low being a little bit further west, it doesn't really blow up until a bit later off the coastline. So there's definitely some big differences between the NAM and the GFS, even though many of the models, majority of those models are showing this northwestward shift. That's a big difference in the location for that high on Wednesday there. Geez, look at this beautiful nor'easter. The entire state of Pennsylvania is going to get dominated by this thing. 1039 high up there in eastern Canada. That's by Wednesday evening. By 12Z tomorrow, the NAM has that high, 1038 high there over eastern Quebec, due north of the Adirondacks. And the GFS actually has a stronger high due north of the Adirondacks. That means a deeper air mass, deeper cold air mass all the way down, dominating the northeastern U.S. Just some subtle differences. I'm hearing that they're sending the NOAA Hurricane Hunter aircraft out there to get some more data points to ingest in these models for this nor'easter. That's good news to help improve the model forecasts of these things. Look at that difference still. Both of these forecasts are for 12Z Thursday morning. The GFS has that low just offshore of New York City. Still getting hammered by Thursday morning there in the Big Apple. Wow, look at that transfer of energy. The NAM still has that surface low just off of New York, but it transfers a new surface low just off Massachusetts more quickly than the GFS is showing. This is almost like an occluding tornado. The new tornado's on the ground off to the east. Not too terribly dissimilar from the Pilger, Nebraska situation. Obviously a different scale out here, but there's a lot of similarities between the different scales in meteorology. So really the GFS kind of holds this western low as the dominant low for a bit longer before transferring to this new surface low. This early transfer, though, allows for coastal Maine, eastern Massachusetts to really get hammered by this. Probably some near blizzard conditions out there with that. But still some subtle differences, quite a bit of differences between the individual models and even within the NAM. So the high resolution NAM just really blows up this westward surface low. Still has a double-barreled surface low, but the NAM really bombs out this western surface low here on the western side down to a 993 low out there, right off the coast of New York City, 12Z. Still some big banding, hammering New York City. Very tight isobars as well, right along the west side of that low, close together. That big northerlies, northeasterly winds through the Big Apple, extending through tomorrow morning. And probably a line of storms here, maybe some water spouts offshore over the open Gulf Stream in the warm sector of this system. And look at this low-level jet. Warm conveyor belt transporting all this moisture. That's the 850 low. Look at that low-level jet. This is Wednesday evening. Big conveyor belt of moisture getting thrown into that colder air. Right on the nose of this low-level jet is where the heaviest snow should fall. Closer to the core of that low-level jet, you're going to mix changeover with sleet. All rain as well. But really the nose of this low-level jet, that's where the heaviest snow is going to fall there. And look at that low-level jet really ramp up overnight Wednesday. 850 low there, centered right over eastern Maryland. This massive photograph here, that shows you big warm advection regime happening there. You're going from east-northeasterlies to a big south-southwesterly low-level jet, 70, 80 knots right there. Giant hook-like photograph there. Big warm nose, sampling the warm conveyor belt of this system. I think eastern Massachusetts is going to get hammered by this one as well. Thursday, this is at 10 p.m. Still getting those big northeasterlies ripping off the ocean there into eastern Massachusetts. You can see that here in Boston getting hammered. This is a 3-kilometer NAM. showing well in excess of a foot, 14, 15 inches there. Eastern Mass. So really the only thing that's preventing this from being a record-breaking storm is the speed at which it evolves and moves out to sea. This is a slower moving, more buckled of the upper level system, with the upper level features gaining more of a negative tilt there, more positive feedbacks, slower moving system. And we'd be probably talking about 30 or 40 inches out here. And also there's a lot of differences between the Cuchera and the just standard 10-to-1 snow to liquid ratio. So I used to look at these snow maps and try to find the highest totals here. I'm not an expert on liquid to snow ratios, but there could easily be approaching 2 feet out here, central, northeastern Pennsylvania, higher terrain there of southern New York. I'll do some research on these liquid snow to liquid ratios and a live to the Facebook supporter community. We'll go over that once we launch the Storm Chase EDU type content. But you can see how the high resolution NAM resolves these individual ridges in there. Some banding, definitely resolves the topography a bit more. Here's one down in Northern Virginia that's going to get hammered. So really the Winchester area into the panhandle here of West Virginia and Maryland, west of Hagerstown, especially with this northwestern shift. Cumberland, up toward Chambersburg, State College are going to get hammered. Scranton, Allentown, southern New York. So here's what I'm saying with my forecast. I think that when you have a 1038 high up there in eastern Canada, the depth of the cold air is going to be so substantial that you're going to have a period of big-time snowfall rates even before it shifts over to a mix. That's why I believe more of the GFS model, having this stripe in excess of a foot right along the coastline, including New York City, but still the highest totals being over the higher terrain there in central northeastern Pennsylvania. I think Massachusetts is also going to get hammered. But it seems like an outlier, the models that transfer to that new surface low rapidly. I think that the 3-kilometer NAM kind of solution, having a dominant western surface low there for a longer time period, seems more accurate as well. But definitely a northwestern shift. We're going to have to go through the morning models and the 0Z models tonight before we make a final decision. But here you can see over a foot even in northern Virginia. Hagerstown gets hammered. Exciting weather happening here. I'm excited also for 12Z GFS to come in, or the 12Z European to come in to see if it supports this. A lot of times the European will be a little bit closer to the NAM solution, so I wouldn't be surprised if New York City has a bit less snowfall right along the coastline, more similar to the NAM agreement. But look at that massive slug of snow and quite a bit of agreement, at least in the location of where that bullseye happens, central northeastern Pennsylvania, southern New York. But keep the door open for a lot less snowfall in New York. If that warm nose is stronger and that leads to a changeover to a mix of precipitation, that can certainly happen. But I'm going to be going live on Facebook and YouTube starting early tomorrow morning, 24-hour stream. I'm going to be heading north up toward by far northern Virginia, and we'll be streaming continuously the entire duration of the storm on the southwestern side of that snow max up there. And thank you guys for tuning into my weather reports. Thank you, Facebook supporters, for making the live storm chasing possible. Hope you guys enjoy my weather reports tomorrow. I've done a couple of snow chases already this year, but this is certainly the biggest snow I've covered all year this year. I'll easily be able to drive through that. I'm going to have my winter weather safety kit on there. I've got snow tires that can pound through anything. So everybody, make sure you get the bread and milk ready because this snowstorm's coming in. It's going to be some wet snow, a lot of power outages out there. All eyes will be on the northeast with this system. Definitely some bust potential if you live in New York City right along the coastline. especially if this northwestward trend continues just a little bit. So thank you, everybody, and definitely dig deeper into these ensembles on the weather.cod.edu website. When the European comes out too, it'll be very interesting to see how that looks. So thank you, everybody, for tuning into my weather reports. I hope you enjoy the snow chase during the day tomorrow. Never stop chasing.